This conference will now be recorded.
Hello and welcome to the Elite Testers Sunday Meetup. And today we have a very interesting session by Mr. Ramit Manohar Kaul. Ramit and I met in 2016, I guess, in Bengaluru. And uh, what I liked about him is he encouraged me for doing lot of things, specifically in software testing. I'm not saying, you know, automation or something, but software testing. And he supported me. He no. So and I learned so many things from him. So the one thing I always tell in this meetup, if you go through my previous recording, Ramit coached me or Ramit mentored me, said that Nagesh, read at least one page every day or whenever you get time, at least one page from any software testing book. And I took that, I took that suggestion or advice, whatever you call it, or blessings from Ramit, and I started doing that. And so that's why I think that we should invite Ramit to this call, and Ramit will help us in going forward in our career. So welcome, Ramit. Ramit sir, welcome to this meetup. Over to you. I will be on the mute now, and I will be on off camera. So welcome again. Thank you.
Thank you very much, Nagesh sir. Thank you very much, and thank you everybody for taking time out on a Sunday. First of all, I know Sunday, irrespective of whether we are working from home or not, I know working on Sunday or doing something on Sunday apart from your normal daily routine is a difficult thing. So taking time out on a Sunday itself is something which is uh, which is kind of phenomenal. Okay, I'm turning my camera on just for a second if I can. I don't know I can or not. I don't think my camera is switching on, but that's okay. I have to share screen with you, which Nagesh, I think I cannot. So if
I will do that thing, sir. Okay. Please check now.
Yes, I can. Okay, great. Okay, guys. So what you see actually is a blank Excel sheet on which we are going to use it as our drawing board, and this is where we are going to use the sheet and try to learn a few things. So you already know that today's session is about test design techniques. I hope you guys can mute yourself at any point of time and you can ask me any questions. That is a privilege that you all have, unlike where you cannot see it. I think you can unmute yourself and can ask a question at any point of time. Whenever you have a doubt, please feel free. Today we are primarily going to talk about two techniques which people think are very easy. People think that they know these techniques very well. People also assume that these techniques are very simple to use in a day-to-day life. But what we are going to do is we are going to see these two techniques today, and then if you guys are interested, we can take further sessions going forward where I can tell you about a lot of techniques. So today I'm going to focus on two very basic test design techniques. You would have heard about them thousands of times in your life. One is boundary value analysis and another is equivalence partitioning. Now you might think of, oh, are we really spending 1 hour? Is it enough? Is it really worth to spend 1 hour talking about these two techniques which almost everybody think they know? So let us give me 1 hour and then I will ask you again after an hour whether you have got anything new about these two techniques or not. So let us start with equivalence partitioning. Can anybody who is present here in the audience tell me what is equivalence partitioning? What is your understanding of equivalence partitioning? There are a lot of people here. Can you tell me what is your understanding of equivalence partitioning? Anybody can unmute and can tell me. No one? Seriously? You can also use chat. Yeah, please.
I will take it, Ramit.
Yes, please. Yes, please.
Okay, so in equivalence partitioning, what we are supposed to do is, or what we are doing is, we are having a set of you can say the values which we are supposed to enter in the particular field, okay, as a
Okay.
parameter or as
Hmm.
input. Okay. So we are
Okay.
taking some apart the whole set. Instead of putting 1 to 1000, we are taking some one or two values from, and we are dividing the whole set of values into small sets, and from there we are
Okay.
picking one or two values and we are just entering it there.
Okay. Fair enough. May I know who is calling, because I can only see your name as phone caller.
Okay, my name is Sachin Sharma.
Okay. Oh, Sachin. Okay. So Sachin, we all know that we take one value from each set and all that. So typically, how an equivalence partitioning works is, if you will remember it from whatever books or whatever blogs or whatever, whatever the things you have read, typically people divide their data into multiple sets, and what they do is typically they take one value from a particular set. Okay, so they will take one value from this particular set, then they will take one more value which will be from this set, they will take one more value from which is from this set. Particularly, this is what people do. And then equivalence partitioning says that once you have taken one value from each set, okay, if you have taken one value, let's say from this particular set, and that value gives you a typical result, you will assume that all other values from the same set will give you a similar kind of result. Boundary value analysis is the same concept but taken at the boundary, where you think that at the boundary values you should check all the boundaries. So for example, if I have a requirement which says a person can buy uh, insurance, and this insurance can only be bought if the person is more than, let's say, 18 years old, or person is less than 75 years old, uh, such kind of requirements are the classic case of usage of equivalence partitioning and boundary values. So if I have to make a boundary, if I have to make a equivalence class, I will make a equivalence class which will be I don't know why my pointer has stopped working. Okay, so if I have to take one equivalence class will be right here between 18 to 75, another will be more than 75, another will be more than 75, and the third class will be less than 18. So the idea here is why I'm saying that this will be one class, or between to 18 to 75 will be one class. This is because the output that I am getting from the system is dependent on, or the output that I'm getting for such system is common for this particular data set that you can see in red right now. And if I change this color, for example, let us say I make it red, right? Sorry, red is already there. If I make it green right now, which actually, so from these data sets, these values should not be accepted by the system to sell a insurance. This is the basic premise. Now, where is the problem here? The problem here is that that my system says if I take one value from here, if I take one value from here, and if I take one value from here, my equivalence class partitioning coverage is complete. However, so if let us say I take one value which is, let us say, 18 here, or let us say 19 here, I take one value from here which is, let us say, 100, and I take another value from here which is, let us say, 15. Equivalence class partitioning says you take one value from each set and you should be done. Boundary value analysis says no, you should, if 19 is passing, chances are that the other side of the boundary, which is 74 or 75 in our case, that might fail. So the idea here is that one technique is talking about one thing and the other technique is contradicting it, and still these two techniques are connected together. So where is the problem? What are we trying to learn? So this is where having a deep knowledge uh, having a deep knowledge about the techniques is going to help. So today what we are going to do is we are going to dig deep into these techniques, first by going through the basic understanding of the technique, and then we will go deep into the technique, and in this knowledge we will try to identify how these techniques can work in different scenarios. Having said this, my friends, you should remember that overall, whenever you think of test design techniques, okay, and I'm writing it for you here, when you think of test design techniques can work on a single variable of your system, okay, or it can work on multiple variables, which is the combination of multiple variables can be used in the system. Equivalence partitioning and boundary value as a coverage technique is a single variable technique, whereas the techniques, oh, right now my camera has switched on finally, okay. Okay, I'm just switching it off right now. And the techniques which come work on multiple variables, these techniques are typically known as combinatorial testing techniques. For example, pairwise testing is a very common and very known technique for combinatorial. Then you have classification tree, which is a very known technique for combinatorial testing. Decision tables is also a very well-known technique for combinatorial, whereas state transition testing, depending on how you create your state diagrams, can be a single variable technique or can be a combinatorial technique, given that how you use it. Okay, having said this, let us come back to our agenda, which is equivalence class partitioning and boundary value. So I told you, in boundary value testing, what we do is we typically think of dividing our data in such a way that that particular data gives you a similar kind of behavior. That's why all these techniques that I have taken names, they all are known as behavioral based techniques, where you test the behavior of any software. So going back, what we were saying is that if somebody's insurance has to be bought, and if the insurance is, let us say, the person can only buy insurance if the person's age is more than 18 or less than 75, we can already see that we have an example here which talks about that you have one equivalence partition here, and that's why it is equivalence partition. It is not equal partition. If it was an equal partition, I would have taken 0 to 10, 11 to 20, 21 to 30, 31 to 40, which is equal partition. So my friends, please understand the difference between equal partitioning and equivalence partitioning. In equivalence, we are looking at the equality in terms of the behavior of the system. Now, having said this, we have now seen that there is a way to divide our data, and this data here, this set particular here, where the insurance can be accepted by the system or the age of the person can be accepted for the insurance, is taken as the valid data set, and rest of them are invalid data sets. So this is the base technique. Now we will go and start going deeper into this technique. First of all, for example, is there only always valid and invalid values in equivalence partitioning? My answer is no. It all depends on the context. For example, if you look at the current taxation system in India, income tax system in India, up to what, 5 lakh rupees, there is no tax. Okay, so the tax that government takes is 0%. From 5 lakhs to 10 lakhs, government takes, I don't know, 5 to 8, I think, or whatever that is. Let us assume right now that this is our answer. You know, this is the taxation system. 5 to 10 lakhs, let us say government takes 20% of the tax. And from 10 lakhs to, let us say, 3 crore rupees, we have a taxation which is 30% of your total income. Beyond 3 crore rupees, government takes 30% tax, plus it takes 3% of cess on the top of your tax value. So a lot of people think that there are only brackets which are up to 10 lakhs. No, there is a bracket which is beyond 10 lakhs, which starts at 3 crores. Now the government has changed it to 3 crores and I think 5 crores, where you have cess of 3% on the tax at one and 6% of cess in another. What I'm trying to tell you is that now you have a lot of these okay, so let us do this just to make it better. Okay, so now you have different kind of boundaries that you are creating. Okay, so you have one boundary which is, let us say, you have one boundary which is, let us say, up to 5 lakhs. You have another boundary, you have another boundary, you have another boundary, and so on and so forth. So you have a one value which is up to 5 lakhs, then between 5 to 10, then between 10 to 3 crores, then 3 to 5 crores, and more than 5 crores. All these equivalence partitions that you see here, they all are valid partitions. Okay, so on these partitions, you will have to pay some sort of tax. It can be 0%, it can be 10%, and so on and so forth. It all depends on what you are trying to test. So here, there is no invalid partition. You cannot say, oh, I am not earning money, so government should pay me back. Okay, so my total earning this year was in negative 5 lakhs. So government should actually pay me 10% of money. That is not possible. So government says, if you don't earn, you don't pay tax. If you earn, you pay tax. Okay, taxation is a one-way street. Death and taxes are the only certain things in this world, nothing else. Okay, so having said it, you understand, we have now two examples. One example where you see that you have one example. Oh, where is my mouse? Why my mouse is okay? So you have one example where you have two invalid values and one valid value. You have another example where you have all the valid partitions or all the valid values. So idea here is that in equivalence partitioning, you take one value from each set now and you try to test it. Then there is another example which may be where the equivalence partitioning may depend on something else. For example, for a month, my friends, the date can be a valid or an invalid input depending on which month and which year I am talking about. So for example, 29th February can be valid or invalid depending on whether it is a leap year or it is not a leap year. Okay, so 29 can be valid, 29 can be invalid. So as a tester, when you are entering such inputs, you should be very, very clear. So this is the base premise on which entire equivalence partitioning works. I will talk about the basic premise of boundary values as well, and then we will go into little more deep into it. So let us see what is boundary value. Now, boundary value says that for any system that you have created, my system is acting very weird today. For any system that you are testing, okay, still doesn't happen generally, but that's okay. So let us see the first example here. Our first example was insurance, where the person can buy an insurance if the person's age is more than 18 but less than 75. So here what we are talking about, we are essentially talking about '18, okay, and 75. So I am talking about, so the age was, I think, less than 18, okay, more than 18. So that means you can only buy if your age is 19. At 18, the system should reject, okay, and okay, just hold on. 18, and this is wrong cell. Okay, 18 and 19, and the other age was 70, less than 75. So this is 74, and you have the other age, which is 75. Very nice. Somebody has a question, please feel free. Unless your kid is acting up like my kid, then everything is okay. Somebody is unmuted. I can't see anybody unmute. I don't know why. Okay, guys, boundary value says for any equivalence partition that you have identified. Please understand, boundary value analysis is built upon equivalence partitioning. So once you have identified the equivalence partitions in your system, Then you talk about the boundary value, where boundary value says that for any given system, you should check minimum -1, maximum plus 1. Now this 1 here that we are talking about is not 1 as a static number. So in lot of places you will see this minimum minus delta being used and maximum plus delta being used, delta being the lowest factor that you have to add or subtract in your boundary. So in our age, for example, this example 18, 19, so minimum value, minimum minus delta, maximum and maximum plus delta, where you should remember that 18 is a negative value, 19 is a positive value and system should accept it, 74 is a negative value, positive value, and 75 is a negative value that system should reject. So 19 and 74 pass, 18 and 75 should fail. Having said this, the first question, and that is where we will start going deeper into it now. Okay, first of all, understand equivalence partition says if I take 19 and if 19 is passing, as per equivalence partition, 74 should also pass. Boundary value says no. So what should we do now? Which technique is better, equivalence or boundary? A lot of people straight away jump to this answer that boundary values is better. No, it is not the case. The secret here is that whenever you have an ordered set of inputs going into the system, use both boundary values as well as equivalence partitions. Okay, whenever you have an ordered set going into the system, use both equivalence partitions as well as boundary values. Having said it, let us go a little deep into our system. Any questions so far, anybody?
Sanjeev, can you just elaborate on what you said?
Sanjay sir, I was not able to hear what you said.
Can you elaborate on what you said in terms of equivalence and the ordered set, so that you can give an example, please?
Okay, so what I am saying is that in equivalence partitioning, as I told you, that in equivalence partitions, you have to draw the equivalence partitions as per your understanding, as per your inputs. For example, if this is my taxation range, where a person has to pay 0% tax, 20%, 30%, and more than 30%, depending on the income of that person, you will need to draw the equivalence partitions here. So one equivalence partition will be up to 5 lakhs. Another partition will be more than 5 lakhs but less than 10 lakhs. Third will be more than 10 lakhs but less than 3 crores. Fourth partition will be 3 crores to 5 crores, and the last will be more than 5 crores. So these are my equivalence partitions now. How many? 1, this one, 2, 3, 4, and 5. So these are my 5 partitions, and the idea here is that for these 5 partitions, I should take one value from each partition and I should test it. Not necessarily the middle value, any value from that partition. And then boundary value analysis says that for these partitions, check the minimum value of the boundary, minimum value of the partition, minimum minus 1 value, maximum plus 1 value. So for example, now I have a partition. Let us take another example to understand it further. Let us say I have in India, let us say people who are less than 18 years old cannot vote. Okay, and people, and I'm only talking about boys, for example, taking one boys as an example, and boys who are less than 21 years old cannot marry. Let us say for this system is accepting all the ages between 0 to 99. Okay, so this is the premise on which I'm building my example now. So what I'm saying is that for any such system where I am building my equivalence partitions, I will have the age range which is between 0 to, I'm sorry, I don't have my writing pad with me today, so bear with me on this. 0 to 99. Then you have an age which is 18 years to 21 years where the person can vote. So the person if is at 17, and then you have another age which is here 18 to what, to 21, and then you have another age which is 22. So what I'm doing now is that I have created different equivalence partitions, 0 to 17 as one partition, 18 to 21 as another partition, 22 to 99 as a third partition, and then you have fourth partition which is above 99. You have a fifth partition which is less than 0, negative numbers. So what you do is you will take one value from each partition. So whatever value you want to have from here, one value from this partition, one value from here, one from here, and one from here, 5 values, which will give you a coverage in terms of partitions. But when it comes to boundary value analysis, you need to understand for every partition what is the minimum and maximum value. So for example, this is one equivalence partition for you, 0 to 17. What is the minimum value here? 0, 0 minus delta, so 0 and minus 1. Just changing the color to tell you what we are trying to do. So I have minus 1 here, so that becomes one boundary value, 0 is another boundary value, 17 is the maximum value of this particular partition. So let us call it as partition 1, this is partition 2, this is partition 3. I will say this is partition 3A. I will talk about it why I'm calling them 3A. Really doesn't matter what you call them. Let us say this is partition 1A. 1, 2, and 3 as 3 partitions are my valid partitions as far as system is concerned. System should accept this age. Now, after accepting the age, what system is allowing you to do, that's another thing. But system is allowing this age. 0 to 99 is allowed as an age. Okay. So for partition number 1, minimum is 0, 0, minimum minus 1, maximum 17, maximum plus 1 is 18. For partition number 2, my boundary values are minimum 18, minimum minus 1, 17, which has already been covered, 21 and 22 on the maximum side. And for this partition, 21 and 22, 99 and 100. Now, out of these values, you will find that 100 is an invalid value for the system, minus 1 is an invalid value for the system, and for the valid values, what should I do? For the valid values, system should accept this value, but should not let the person either vote. So as far as voting is concerned, this person cannot do it. Person cannot marry as well. In the next system, system should accept, vote is okay, but marriage is not okay. So you can choose your prime minister, but you cannot choose your wife here. Next, you can vote as well as you can marry. You can choose your prime minister as well as you can choose your wife. I don't know which of the decisions will be correct, or both of them will be correct or not. That's another debate for another day. Okay, so now you have these different results coming for different partitions and different boundary values. I hope this clears the basic premise of boundary values and equivalence partitioning for.
Yeah, thanks.
Yeah. Okay. So with this now, let us go into little more and dig deep into these techniques. Now let us say I have a screen. I have a screen on my system which has multiple inputs. Okay. Now this screen can be for your desktop application. This screen can be for your web-based applications and so on and so forth. Let us say filter screen when you go to, let us say, Amazon or Myntra, or let us say you go to Flipkart or any place, and you have filters there where you can select multiple filters through different checkboxes or different drop downs or different places. You can use this particular system. So let me give you an example and will tell you how you can create test cases for equivalence classes and boundary values. A lot of people would have told you about the techniques, but a lot of people will not give you an idea of how coverage can be achieved out of equivalence classes and boundary values. So let us see one of such cases. let us say my system is, or let me see if I have some ready. Okay, I have a lot of things that I do with my trainings for people. One of them is right here. Okay, I am copying it and I am taking it to our example. Very nice. I hate it. Okay, too big. I hope everybody can read it on the screen. Okay, for an insurance product, insurance is only valid for the age between 18 to 75. No extra premium, blah 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 blah. So there are a lot of things that are happening in the system. My daughter is, hearing this blah blah and probably thinking of what I'm doing. Anyways, so let us first identify our different equivalence classes here. Now, friends, you will see that I have two distinct things that I need to check here. What are these two distinct things? One distinct thing is age, and another distinct thing that is coming out of the system is BMI. So what I need to do is, first I need to identify what my equivalence partitions are for age and BMI. So let us try to find them. I have age, and I'm saying age 18 to 75 is valid. Okay, then I say age less than 18 is invalid. Then I am talking about age more than 75 is invalid. Age cannot be a number, Okay, so making it easy, not a number. Age not a special care. Okay, and so on and so forth. Now it is up to you how many you want to create or how many equivalence partitions you want to identify. This will be based on your understanding of looking at a particular input and how you can identify different uh, equivalence partitions, and then how you can identify different valid or invalid classes about it. I'm just giving an example so that you understand that it is not just that number that we were looking at. Equivalence class is not just about this single line that you have created. Equivalence class goes beyond that single line. For example, not a number, okay, or not a special character or anything else, not from the same font family, not from same something else. So it is up to you how many you want to identify. So I've identified age, then I say BMI. Now BMI, because there are different outputs of BMI, I am taking them. For example, if BMI is less than 25, if BMI is between this, whatever it is, I know this is going to create trouble, so I'm just changing it. Okay, then you have another one where BMI is more than 28 and so on and so forth. God bless the copy and paste. And you have more than 30. Again, you can have BMI is 0, which is not possible, which cannot happen. BMI is not a number, BMI is a special character, and so on and so forth. So I have identified these things for BMI as well. So I simply put them under one bracket. And now what I do is, and this is where, my friends, you have to be with me and understand the beauty of how to create test cases for this. Please be with me right now, because this is where the criticality or the understanding comes into picture. Okay, so I'm just making sure that we have these things very, very clear. I'm just making few changes. One, and then I have thick border, and I have a thick border. Now I have two different sets of equivalence classes. Now let us see how I create my equivalence partition test cases for this. Now what I do is, I am simply inserting one more column here, which I say representative value. Representative value means represent this particular class with a value. For example, 18 to 75, I take that representation as 30. Less than 18, more than 75, not a number, special characters. Okay, and same goes for the other side. Got it, guys? So I have now represented these equivalence partitions with their values. Now what I do is, if you see clearly, this is a valid value. Same goes here. This is a valid value that system should accept. Rest of them, for example, for age, are invalid values. I hope you all will agree to this. Okay, so whatever you see in green color are valid values, and whatever you see not in a green color, they are invalid values. So what I do here is I take one value and another one value which is valid from both the sides. Okay, now assuming that there were other valid values, I will, okay, let us leave it right now. Then I have to make sure that my test cases one by one cover all the valid values. And since there is no other valid value for age, I am simply taking it forward. So what is happening here, that these four test case combinations that I have created right now, these four test case combinations starting from 1, 2, 3, and 4, the first four test cases, so it is something that on your screen you have enter age, enter BMI. So for this particular test case that I'm highlighting, you will enter age as 30 and you will enter BMI as 23. Age 30, BMI this, age this, BMI this, age this, BMI this. So in the first four test cases, you have covered valid values or valid sets for age. You have also covered valid sets for BMI. But when it comes to negative values, what you do is you take one valid here, invalid here, and any valid value from the other set. Okay, and you keep doing it now. Okay, for the other invalid values. Okay, so be with me for some time and we will see what is emerging out of it. And then you have the next valid value coming up here. Okay, so which is now, okay, so guys, these test cases that you see, if you see them very closely, what you will identify is that, and I will change this color a little so that you will understand that we have a difference here. You will find that what we are doing is that everything that you see on the top or every column of this table now is actually a test case for you. And what I'm doing is that I take one invalid value from one side and I don't mix it with any other invalid value from any other input of the screen. So at any given point of time, I'm just following one value from each set. Okay, and same goes here. So when I'm taking invalid values here, as you can see in test case number 9, 10, and 11, when I'm taking one value here as invalid, I take valid value from the other set. Why we are doing this? This concept of taking one invalid value at any given time of time, this concept in testing is known as, it will uncover all your defects for those values for the invalid data that you are entering, because you will save yourself from any fault masking or bug masking. So there will be no fault masking or there will be no bug masking that will happen. The concept of bug masking or fault masking is where one bug hides behind another bug. For example, if I take invalid here and I mix it with invalid values of BMI, your system might show you an error message, but you will never be clear about whether the error message is because of the age or because of BMI. Also, these 11 test cases give me full coverage in terms of all the valid and invalid equivalences that I have identified for age and BMI. Now, let us say there was a third category here. Weight of a person, if it is between, let us say, less than 60 kg, you will do something with that person. Let us say you will give that person a different discount. Let us say if the age is between 60 to 80, you will give this person little more discount, lesser discount than compared to 60. And if the age of the person is more than 80, you will not give this person any kind of discount. Okay. Now, weight cannot be a number. Weight cannot be a special character. So you have now another category that I'm building up now. So now I have, let us say, these three classes now available. So how this will impact my table? So let us see how this will impact my table. So I go and go for all borders, and then I do a thick border. Now, my friends, again, whatever the representative values I give here, now you all will understand what is the representative value. But let us see how this will impact my table. This will be very, very surprising for you. So in the third test case, I will not change anything here. It still goes okay. And this is my fourth test case. So absolutely no difference in terms of test cases where system should accept everything and should give you a discount or anything. Now, a lot of people here question me that, hey, Ramit, there is no combination that we have identified. For example, BMI of less than 25 has not been covered with weight category of 60 to 80 or more than 80. You are just taking one test case here and you're saying everything has been covered here. Please understand, and I will take you back. Every type of testing or every type of technique either focuses on a single variable or focuses on the multiple variable. Equivalence partitioning is a single variable thing, so it will only check whether your weight category has been covered or not. It will only check whether BMI has been covered or not and age has been covered or not. But because all these three, age, BMI and weight, are on the same screen and there is a single submit button for entering these three categories, you need to have some combination going in your testing, and that combination is being created here. If now you want to check the combinations of age, BMI and weight, then you might have to switch to a technique which can be, let us say, decision tables, which will give you the combinations of different things. But then that is combinatorial testing. That is not single variable testing. Equivalence partitioning and boundary value is a single variable testing. It focuses on the coverage of a single variable. But what will happen to these negative test cases now? So if you think about it closely, you have now two more invalid classes here for weight category, and these invalid classes will come right here at the end, where you will choose 1 and 1, and what you will have here is that you will have a third category going here, where you will take these two values and any valid value from any other area. Okay, so I take valid values from the other area, and now with two more test cases, you will have the complete combination going. So this is the way you create your test cases out of your equivalence classes and boundary values. Now, where can you use these? You can use them in testing which is human driven. You can also use the same things in your asserts that you write in automation. So if you are writing asserts in automation, or if you want to check whether your testing is complete in automation or not, these all are your combinations for asserts, where in assert you can write if, and if this happens or not, and then these assert conditions we can tell you every single day whether your equivalence classes or boundary values are covered or not. You remove these equivalence classes and you put boundary values here, minimum -1, maximum +1, and you will still have similar kind of combinations coming for your boundary value test cases as well. But this table that we are creating is the core of the coverage part of your equivalence classes and boundary values. I will stop here for a second and I will ask you, have you understood this table or not? Do you understand how to create test cases out of these two techniques or not? Yes or no? Any questions here?
Yes, Ramit.
Yes,
Yeah,
Kapil, you have a question?
Not question. I understood what you said.
Okay, good. Anybody has any questions so far?
I have one question.
Ramit, I have a question.
Yes, please. So I hear a girl
English is there.
speaking, so I'll probably give that girl first chance for a question. Please go ahead.
Okay, Ramit, it was about the weight. Since we had just three valid cases, we marked that
Yes.
tick against all of them, and fourth, we just I think ticked, just because we had to tick somewhere, right? Because we were covering four test cases already. Is that true?
Sorry. Say it again. Say it again. Sorry.
For the weight rows, like for the valid cases.
Okay. Yes. Go on. I'm just changing the
Uh,
colors to match them with
yeah.
what I was doing. Yes.
Mhm, mhm. Okay, so for the weight rows, I'm saying that there are three valid cases, right? And against all of them, you have marked true, like for less than 60, 60 to 80
Okay.
and greater than 80,
Okay.
right?
Okay.
And then
Okay.
fourth one, you
Yes.
just take just because we had to, because we had prepared four test cases already for the valid cases, right?
No. It is not like that. See, for BMI, you have 4 valid partitions.
Yeah.
So the fourth test case is covering that partition. Fourth test case is specifically covering this partition. Okay.
Yes.
Because you have already covered the valid partitions of other areas, you are simply repeating any value from the valid side. Now, let us say there was another category, or let us say there was something like this. I'm just telling you guys. Let us say there was something like this. Just for a second, I'm just to clear this doubt, guys, nothing else. Let us say I have another valid case here. Okay, so you see now for BMI, I have 5 equivalence classes which are valid in nature, but for age I only have 1. For weight I only have 3.
Yeah.
Now in the first test case, you cover valid of 18 to 75, you cover valid of less than 25, and you cover valid of weight less than 60. In the
Yeah.
second test case, weight has already been covered, so you repeat that particular value, but the other value of BMI has been covered here, other value of weight has been covered here. In third case, more than 80 has been covered for weight, BMI third value has been covered. So your age category has been covered, your weight category has been covered as far as the valid are concerned, but BMI is still to be covered. So you have in these 3 third cases only covered less than 25, 25 to 28, 28 to 30. You have not covered more than 30 and valid, the 2 remaining equivalence partitions. So you need more test cases for them. One here, and you will have another test case here. So now you see that the same table now has 5 test cases which are kind of where the assert should give you a positive answer. Okay, so it all depends on how many valid equivalence partitions you have identified in the system. You need to cover all of them, and valid generally have to be covered with other valid areas.
Okay, yeah,
Got
that
it?
clears my doubt. Yes,
Okay.
sure. Yeah.
So there was another question coming from someone.
Yes, Ramit, I had one question. So,
Yes.
when we are designing the invalid scenarios,
Yes.
negative test scenarios, so we need to understand the story behind what we are testing, and that many scenarios will come up, right? So, when we want to add some more negative scenarios to this kind of template, and I want to expand this, so does it always go like I just add one of the rows and add one more additional column and then just mark it down? Like if I want to expand this template, how can I do it?
So it is up
So
to
that
you. See. The right answer to this question is, end of the day, you need to understand the core concept. Now, once you have understood the concept of what we are doing here, then it is not necessary that you need to follow this table. Now it is up to you whether you want to change rows into columns, columns into rows. you want to use something else, you want to use plain piece of paper, that all is on to you. The table, why I create the table is because with table people can understand the concept very easily. Okay, because with table it is very easy to tell you that this is the way coverage has to be done. The table is more from the coverage perspective rather than from the template perspective. Don't templatize these things, okay, unless there is a template. For example, decision table has to be a table. No, you cannot do anything there. Okay, so what you can do here is the real problem comes in identifying these negative equivalence partitions. You can go on and on and on, it is up to you. But you should understand that too much of negative test cases, you might be doing a lot of redundant testing where you are repeating your same work again and again. Okay, so you need to be careful there.
Ramit, one
Hello.
question.
Yes, please.
Hello.
Yes, go ahead. Ramit, one question.
Let him speak. I'll speak later.
Hello. Yes, so Anshu this side. So I missed something weight के बारे में actually internet का थोड़ा सा issue था. तो why we left 6 to 12 number of column जो है वो left हमने weight के लिए empty क्यों रखा हुआ है?
कौन सा अंशु, कौन से की बात कर रहे हो, बताइए फिर से.
सर वेट के लिए कॉलम नंबर 6 से 12 तक हमने
नहीं रखा है. देखो फिर से टेबल को.
नहीं, अभी हमने फिल किया है, मतलब वो पहले जो छोड़ा था वो कुछ स्पेसिफिक.
वो तो यार अब समझ जाओ ना अब इस बात को कि उसको तो फिल करना ही करना है. उसके बिना देखो डाटा जब तक आप स्क्रीन पे डालोगे नहीं तब तक आप आगे कैसे जाओगे. सो द आइडिया हियर इज दैट यू शुड फिल, you should be able to enter the data at any given point of time, and you should keep, without filling the mandatory data you cannot go forward. But the idea is that one system is, or the one area is already checking negative. For example, if you see between 6 to 9 you are checking invalid partitions of age, between 10 to 12 you are checking invalid partitions of BMI, and between 13 and 14 you are checking invalid partitions of weight. Whenever I am checking invalid partition at any given point of time, you see other values of that column will always be positive. For example, any of the values you see, whatever the areas I have highlighted now, you look at any column here, you will see only one invalid value going into the system and other values will always be valid. For example, any value you take. For example, if you take column number 10 or test case number 10, you will see age value is valid, BMI is invalid, and weight is valid. So only BMI invalid is going in. Or if you take 14, you will see age and BMI going as a valid value, but weight is an invalid value. So at any given point of time between 6 to 14, you will always see that you have a valid value, only one valid value, and the rest of the values are only one invalid value, and rest of the values are valid. That is how you need to design your equivalence partition test.
Okay.
So somebody else had a question.
Yeah, Ramit, I have a question. So in the start of this session, we had discussed like what exactly, मतलब equivalence partition कैसे काम करता है, boundary value कैसे काम करता है, and हम लोग ने ये we had said कि we have to check for boundary value, we have to check m-1, m+1, like the proper boundary values, and that was, we felt कि it is a better than equivalent partition. बट ये हम लोग ने टेस्ट केस तो सिर्फ इक्विवेलेंट पार्टीशन के बेसिस पे बनाया है, बाउंड्री वैल्यू के हिसाब से.
मैं आपको क्या देखिए, पहले तो सबसे पहले ये समझिए, मैंने बहुत सारी बातें इसके बीच में बोली है मेरे भाई. आई एम वेरी सॉरी टू कट यू इन बिटवीन. आई एम सेइंग दैट वन, whenever there is an ordered set of inputs, we should check both invalid, we should check with both equivalence partition and boundary value analysis. We should be very clear about it. First of all, whenever there is an ordered set of inputs, we should check with both equivalence partitioning and boundary value. ये एक बात हो गई. Another thing that I'm telling,
Ramit, just a point here. Now it's a point which from the very first minute of the discussion that keeps running on my mind is when you said that both the concepts are contradictory each other.
No,
Okay.
I'm not saying. I am saying that it looks like that concepts are contradictory. I said, देखो sir, I'm very sorry if that
No,
was the
worries, no worries. We are all here. I'm just looking forward for that. You can continue with the answering the question. That's it. No worries.
Yeah. So I am saying that they look contradictory because equivalence partitioning says one value passes, but boundary says no, it might fail. So they look contradictory, but they are not. Equivalence partitioning is the base technique. Boundary value is built on the top of equivalence partitioning. Okay. As I told you, to do boundary values, you first need to identify equivalence partitions. But when it comes to ordered set, then there can be different results you will get with the two techniques. So for ordered set of input, use both. For unordered sets of inputs, you cannot use both the techniques. And I was going to give you some examples of that in ordered sets where you can use equivalence partitioning but not boundary value. But that may be little later, 5 minutes into this discussion. I'm trying to answer right now with questions regarding the table or regarding the base technique of how to use it. So I'll be very glad if there are any other answers, then I will continue. तो सर कोई कॉन्ट्राडिक्शन नहीं है इसमें. ऑर्डर्ड सेट ऑफ इनपुट्स के लिए both use both equivalence classes and boundary values. For sets which are not ordered, use only one technique which suits you, and that technique generally will be equivalence partitioning. Okay, and there was something else before I was answering this. Somebody else, कोई तो थे एक सज्जन जिनको जो क्वेश्चन पूछ रहे थे. Somebody was asking a question. After Anshu, somebody else asked me a question जिनका नाम M से स्टार्ट होता है.
मिनाल.
हाँ जी, मिनाल आप कुछ पूछ रहे थे.
हाँ, मेरा ही क्वेश्चन था बाउंड्री वैल्यू का.
जी बताइए. Minal, I can hear you. Please go ahead. Can you repeat your question again so that I will be able to answer you?
नहीं, you answered ना कि हम लोग ने ये इक्विवेलेंस पे
Hello. Okay, I have seems like okay. Yes, please. That will help for unordered. Okay. Parul, I will talk about unordered set. I was trying to listen to Minal, but seems like I cannot. So I will continue, guys. Let me tell you now what is the order.
Of this?
Yes, please.
Yeah. So actually, I'm looking at row number 17 and 25. So instead of putting that horizontally, like 6 to 9, can't we put it like one by one? Because suppose in test case number maybe 6, 7, 8, 9, we are passing the value 23. If we could have created maybe like in maybe that line which is horizontal, instead of that, if it is like 1, 2, 3, 4, 5, a slanting line, it would have covered more.
So you mean to say कि आप इसकी जगह ये कर दो.
Right. So उससे that way we can have a more.
मैं आपको बताता हूँ फर्क क्या. अच्छा, मैं आपको बताता हूँ इससे क्या फर्क पड़ता है. आप कर सकते हो. Nobody stops you from doing it, because this is just an example. You cannot tell everything in an example. The idea here is why I put a straight line is because then it becomes easy for people to see that I have taken a valid value. You can also do this. I agree. Will this give you more coverage or not? See, in test case number 6, 7, 8, 9, my friend, the idea is not about covering the positive values of BMI or weight. The idea here is that for the invalid values of age that I am entering, is my system giving me a valid error message or not? Okay. So whatever you enter in BMI as a valid value really doesn't matter here. That's why whether you write a straight horizontal value or you put it something like this really doesn't matter, because your system should give an error on the age, not on anything else. तो सिस्टम तो ये पढ़ेगा भी नहीं कि आपने इसमें क्या डाला है. सिस्टम तो आपका एज की ही एंट्री पे आपको एरर दे देगा. Getting it?
Yeah. Thank you.
Yeah.
Sir, एक छोटा क्वेश्चन था.
I just छोटा आंसर चलेगा सर. छोटा आंसर.
Sir, I was asking that since this is a single valued expression format which we're trying to understand, so if I want to convert this to a combinational format, just from the kind of test case.
Then you have to go to decision table. Then this technique is not enough. See, इस technique का अपना limitation है. This technique talks about a single. इस technique का ही limitation है. Sir, if you have to fire a burst, you cannot use a revolver. You need to change the gun. A revolver is going to fire one shot at a time. ठीक है, वो उसमें ऐसा नहीं है कि that revolver is bad or revolver is not a good weapon. The design of the revolver is such that revolver will only fire one shot at a time. Revolver is not made to fire multiple shots at a time. Now, if you want to make multiple shots at a time, a single barrel gun is not going to do it. Then you have to create multi-barrel guns, and that is where the difference between single variable techniques and combinatorial techniques is. For a combinatorial technique, it can give you those combinations. Then in the same case, you need to use a decision table, not a equivalence partition or boundary. I hope, Gaurav, I gave you the answer. हाँ, ठीक है. तो थोड़ा और deep में जाएं इसके, because we should close this in some time. It is generally a 1 hour session, but it is going beyond 1 hour. And let us go a little deep into it, little more deep, 5-10 minutes, and then we will end this session. Yeah.
Yes, sir.
Okay. So now, अभी तक जो मैंने आपको बात बताई वो बड़ी सिंपल से एग्जांपल्स बताए. अब चलते हैं एक नेक्स्ट एग्जांपल which is about the ordered and unordered set. Now let us say my input is that test all prime numbers between 1 to 100. So what are the 9 non-prime numbers between 1 to 100? My non-prime numbers are, 1 is not a non-prime number, so prime number. So 2, 3, 5, 7, 11, 13, 17, and then 23, and so on and so forth. So what I essentially have now is that I have a set of numbers which is between 1 to 100. I have a set of number which is between 1 to 100, and within that, okay, sorry about it, and within that I have all the prime numbers. And you see, these prime numbers are not in an ordered set. So it is not that every number after one switch or one step, or any number after 2 steps, or it is not that these 2 addition is the next prime number, these 2 addition is the next prime number. So there is no ordering here. Now in such cases, prime numbers becomes one set, because the output of a prime number is in one set, and 1 to 100 rest of the numbers become another set. This set is valid now, and rest of the set is invalid. So ये तो 1 to 100 हो गया. Now you want to expand it further, all numbers. Still you are only talking about invalid, all characters, and so on and so forth. Now it is up to you how much you want to go bigger and bigger into this. So this is an example of a unordered set. So when you have unordered, and I hope this gives answer to people who were probably skeptical about what is this ordered input and not in an ordered input. This is a classic example of order and inorder. And you see here, I am not creating a straight line and then dividing my equivalence classes here. So I've used set theory, and set theory works fine. Let us say another example, which is, let us say the base colors are red, green, and blue. And I want to say that I want to show on my screen only the combinations of red, green, green, blue, and red, blue. That's it. What will I do? So the idea is very simple. In that case, red, green, and blue, red, green, and blue. My friends, your ordered sets are this one. This is valid. This is valid. This is valid. But beautifully in all this, because I'm talking about only 2 combinations, this right in the middle, which is a combination of all the 3 colors, this is an invalid set. This is obviously an invalid set, and this is an invalid set, and this is an invalid set. So now you have 1, 2, 3, 4, 5, 6, and 7 equivalence partitions, and out of that only 3 partitions are valid, which are, I'm trying to show with green color. The rest of them are invalid sets. So here again you can see that I have gone beyond my line, because you can show them like this. Then another example that will be very, very handy for you guys to understand is that I have a password field, and in the password field, I can have 6 to 10 characters, and I can only have, very nice, this happens a lot. I have 6 to 10 characters, and I have only alpha and numeric numbers in this 6 to 10 characters. How will I draw my equivalence partitions here? Again, to draw the equivalence partitions here, what happened? Okay, in order to draw the equivalence partitions now, I should take I want to change the color of this. Okay, this will do. So I need to be very, very careful here. So on one side, I will take 6 to 10 characters. So this is 5 characters. This is 6 characters. Up to what? Up to 10 characters and more than 10 characters. So this is on one side, and then on the other side, show me the colors. Thank you very much. And on the other side, I create a alphanumeric range, assuming that it is ASCII values, and I have alphanumeric range. So I have A to 9, which is my ASCII range. So this will be small a, whatever it is, and then you have one range which may not work. So in this case, what I'm trying to do is that I have now created equivalence classes, and all this that I'm trying to fill now, they all are my valid range, and rest of the things are invalid. Now you can see here, whatever we have learned so far, creating the sets, creating this, all that will go for a toss, because you might have to cover 4 corners, and there might be 4 values on each corner that will give you boundary value analysis. Okay, so now instead of just having 4 values, minimum, minimum minus delta, maximum, maximum plus delta, you have, because the context has changed, your boundary value context has also changed. So this is now going deep into boundary values, plus all this that you see right here. Okay, let me show this by using one color. So this value here, this value here, these values here, they all are your boundary values. Getting my friends? So you need to test all of them properly in order to make sure that your boundaries are checked. Now, how much will you test will depend on how much time you have, how many people you have, and so on and so forth. And then how many values you will take from this equivalence partition now. Again, up to you. Will you cover all these partitions which are invalid? That is again up to you. I will at least cover this partition, this partition, this partition, and this partition at least. So what will you cover now? But this is a deep thought into it, that your equivalence partitions are beyond the line. It can be, as we have seen, sets. It can be 2-dimensional as well. If possible, you can go into 3-dimensional as well, if you are especially taking the help of any tools which are available in the market. And I've already told you, in certain cases, your equivalence partitions and boundary values are dependent on something else. 28 for a day in a month is valid or invalid, depends on year and depends on the month. So 28 is valid, 28 is 29 is invalid for Feb, but 29 is valid for other months. 30 may be valid only for a few months, but not be valid as the last date of a month for many months. 31 can be valid or invalid, it all depends. Time entries, when the date changes, date is dependent on time. So there are a lot of such things where you can go deep into the system and you can understand it. Plus, understand equivalence partitionings doesn't end only on numbers. For example, you have DMG files and you have .exe files. DMG files are good for Mac, exe files are good for Windows. So you can divide your equivalence partitions into files which are DMG, files which are exe. So you can do some testing on it. So environmental based equivalence partitions, data based equivalence partitions, output based equivalence partitions, input based equivalence partitions, and so on and so forth can be covered. Guys, I am a ISTQB trainer. A lot of people in the world have a problem with ISTQB certifications. They oppose it. Some people accept it and do certifications. But I'm telling you, when I train people in ISTQB, especially in the advanced level of technical analyst course, test analyst course, I go deep like this into every technique that I teach my people who are part of my trainings generally. So you need to understand that what is obvious things may go beyond it. There was one question that I will answer again, which was, hey, I have only created a table for equivalence partition. A similar table also can be created for boundary value analysis, my friend, where every column or every row, the way you have designed a table, can represent one boundary value, and then you can find the output of that. So here it is that I'm missing it here. Oh, I should have actually, you should have out of all this, once you have created the table, you should also have the output from the system, what you call as, expected result from the system. So what should happen with this expected result? What should happen with this expected, what is that expected result here? That is also very, very important that you need to write under this table, so that you will exactly know whether your answer is correct or incorrect. And with this, I think I am done for today's session. And if there are any questions, I'll be glad to answer them. Otherwise, we will close this session. Any questions, anybody?
Yes. So you already answered it, but I just want to ask this question for the audience. So throughout my career, I took many interviews, and it happens to be I was supposed to interview a person who himself called as automation tester. So my interview style was, I will ask software testing, craft ones, and all that question, then the automation questions. And so I told him in advance that this will be the agenda and this will be the format. Now I asked the question about equivalence class partition. He said, I am an automation tester, I don't. Okay, so what recommendation you will give to such person who goes with a set mind frame to an interview that I am an automation tester?
The first thing is, you should not use the word tester with his name. Okay. But then he's another guy who can code. If you're talking yourself a tester, then you should know that your automation code is always about asserts. Okay. The entire automation is about assertions that you make, for your system. How will you say a system is running properly or functioning properly or not? Because your asserts in the code pass or fail. I hope my understanding of automation is correct here. If you have any other understanding, then I'm sorry, our understandings do not match. For me, when I do test my system with the help of tools, I generally test my system with the help of assertions that I have written in my code, or assert an equal kind of work which is with assert. How will you write those asserts as an automation tester if you don't understand the basic techniques? So my assumption is that if you are a tester, unlike anything else, you should understand your craft, at least the basics of your craft. And I think whether it is automation tester or human driven testing or any other form of testing, whether it is performance testing or security testing or any other form of specialization that you are going in within testing, the base remains that you should be very, very clear about the different test design techniques. It is similar to the design techniques that typically the design techniques that typically a developer should know if you are going for the job of a developer. And this is something that I said in a recent interview or recent discussion that I had. I talked about Gang of Four, for example. Okay, so you should understand that a lot of things that we have seen in software designing has come from different patterns which have been created, or design patterns which have been created, and these design patterns were created by 4 guys, and then that's why they are known as Gang of 4 guys. For example, you have Eric Gama, Richard Ham, Ralph Johnson, and John Visides, who are the people who have created a lot of different types of design patterns for you. Now, if you're a developer and you don't know Gang of 4, then there is a problem. And if you are a tester and you don't know basic test design techniques, there is a problem. And that is where we have, so all these patterns, factory class methods or factory methods or prototypings or singletons or builder constructs, you would have heard about all these things. If you are in automation and if you have heard, for example, singleton pattern or anything, these patterns have been given by Gang of 4 guys. So if you don't know Gang of 4, In development, you have a problem. If you don't know test design techniques as a tester, you have a problem. This is what my take is, and my take can be wrong. Please understand it. Okay.
Thanks a lot, Ramit. Thank you. Next question.
Yeah.
Ramesh sir, Fayaz here. So I have
Yes.
a question. So you explained about this boundary values and equivalence, and I know like we are stopping here. So could you brief on some other techniques so that we can go search for, which would
See,
be
I can
very
tell
helpful.
you. Okay. Okay, I will tell you the name of the techniques. I don't think we have time for discussing these techniques here,
I
but you can
understand.
look at
Yeah,
yes.
yeah. That
But
name
you can
itself
look
would
at
be.
a technique. Okay, so there is a technique which is based on equivalence partitioning and boundary value. It is known as domain analysis. Domain, and we are not talking about banking domain or any other domain. This is the domain. 18 to 75. This is the domain. Okay, in domain analysis technique, this is said to be a domain. So 18 to 75. That's a domain. So there is something called domain analysis, which is built on equivalence partitioning and boundary value that you can refer to. Now, very, very two powerful techniques, combinatorial, that I know are decision tables and state transition testing. Apart from this, you can always check about classification tree, and you can also check about pairwise testing. Classification tree, and believe me, guys, I am not giving a gyan here. I use these techniques in my day-to-day work. Uh, in my team currently, we are testing a product which has a lot of data in it, and we have used a kind of classification tree to make sure that at least we cover everything. So it is not just Gyan. I use these techniques but wherever I can, I use these techniques in my day-to-day life. Classification tree, pairwise, orthogonal arrays, decision tables, state transition diagrams, domain analysis, they all are very good techniques, and you can read them more on internet. If you face any problems, feel free to connect me. I am available on LinkedIn. I am available on Twitter. My Twitter ID is Kaul Tester, KAULTESTER. You can reach me through my Twitter account. You can reach me on LinkedIn, whatever the way you want to. If you go to LinkedIn, search Ramit Manohar Kaul and you will find me. If you are on Twitter, search for Kaul Tester and you will find me. I am also on Facebook, but then I am not very active on Facebook. It's once in 2 months, 3 months kind of thing. I am also on Instagram, but I don't remember my username, so you can understand how active I am on Instagram. Okay, you can reach me
You
through any of these
mentioned one
places.
more thing, Ramit. Sorry to
Yes,
interrupt.
no
Ramit
worries,
is
no
already
worries.
part of our Telegram group. So
Yes,
what I
yes,
will
of
recommend
course.
you guys, compile your questions, put it across in the group. Whenever Ramit will have time, he will come back to us with the answers, with the explanation, which will help the entire community. We have a lot of members in Telegram. Ramit, is that good?
Yes, there's only one caveat though with this. I help people who do their homework. I am not,
Agree?
this might sound very arrogant or egoistic. It is not, guys. Please understand me. I only help people who have done some kind of homework behind their questions. I don't answer questions which are very basic and there is no homework that I see behind a question. I am very sorry about it. This sounds very arrogant to a lot of people in the world, but I don't help people who don't do any homework. You do your homework, come to me. I will go many miles together with you to help you understand any technique. But your homework is important.
Thank you,
This
Yeah,
is good
Ramit.
point,
Thank
Amit.
you.
This is very important, and this is good point. People like you, me, who are busy with this, people are just keeping questions and making us busy. It's not possible to answer each and every question. To add one more point here is, Ramit, thank you very much for this session. I just want to add one thing. One question is asked by somebody on the automation side. The automation tester don't know about the equivalent partitioning kind of thing. So this is just a conceptual thing that I believe we learn this in schooling also. When we start schooling, even and odd was the first stage when we learn this. Then slightly we move to secondary schools when we learn the sets and unions. Then slightly when we move to graduation and the mathematics, we learn the Laplace theorems as well as the Fourier theorems. So all are the one of the same with the more detailed derived format. For me, as an engineering student, I would go for a more odd ones because I'm a tester. So I would use odd the sets which is not common, and then I'll go for the Laplace theorems because approximation or the possibility of defect is more. And as Ramit said that you have a negative testing which is infinity. So we can do that infinity testing at once upon a time or one time activity. But the steady state that we do on Fourier, considering the Fourier series or Fourier theorems, that will go last longing for our products. So we know the ranges has been given as in boundary or the equivalent partitioning, and we supposed to do our testing within that. So negative range testing, we know that if we use wrong, incorrect user ID or a password, it will throw an error. But the picture comes when you go valid user ID password and still is throwing error. So that's where the valid possibility goes longer than the invalid possibility or invalid inputs. So we always stuck to the Fourier things than the Laplace for a long
Very
run.
well said, sir. Very well said, sir. Especially for the people who think, that Fourier and Laplace and all those things are gone. AI and ML, you will have a very, very solid understanding of mathematics and all these things that, Prashant was talking about. My friends, for the people who are interested in, in artificial intelligence, read about this metamorphic testing. Okay. Equivalence partitioning, the biggest problem is oracles, and oracles are not available, and then you have to do metamorphic testing, which is a new thing coming up. And for that, you need to have understanding of mathematics, especially Fourier Laplace, to understand how a model is working for you. On this note, I will say thank you very much for taking time out. I am done. Almost 1:30, so I need to get going. Sundays is usually my daughter and my son's time with me, and I should now run back to them. I have to watch a movie with my daughter today. That's the promise. So I will get going, guys. Thank you very much. If there are any questions, as Nagesh said, feel free to write them to me in the group. I'm part of the Telegram chat. Feel free to write them to me. Thank you for taking time, guys. Thank you very much. Nagesh, I think we are done.
Yes. Thanks
Thank
a lot,
Thanks,
Ramit,
Ramit.
for
thank you, Ramit. Thank you,
valuable
Nagesh.
time. Thanks all. So I request all of you to, if you're not part of Telegram group, please join. Please subscribe to our YouTube channel, and also there is a LinkedIn page which we are building. So please follow that. You will find more updates there. And I'm really happy today that Ramit is here today, and we learn a lot of new things, to be honest. So thanks a lot. And with this note, we are ending this today's Sunday's meetup. See you on next Sunday. Thanks a lot.
Thanks, Nagesh.
Nagesh, one thing.
Yeah, tell me.
Do we have any other sessions coming from Ramit sir?
We will plan it. I will discuss with
We will
Ramit, and
plan.
then
We
we
will
will let
plan.
you.
Okay.
Yes, we will
Yeah.
plan.
Thank you. Thank you. Yeah.
Thanks a lot.